Good afternoon, everyone.
Good afternoon, everybody. This meeting is being recorded, and we will make the recording available after. We're going to give everybody just a few more minutes to assemble, and then we will get started.
Everyone all set?
Here, once again, we're just going to give it another minute or two, let folks assemble, and then we've got a full agenda for today. All right, I am showing that it is about 2:03 Eastern. Let's go ahead and get started. Thanks everybody for joining. Quick look at our agenda for this afternoon. First up, we'll do a couple of quick announcements and look at what's in the queue for future calls. We'll have a quick opportunity for folks that want to share anything that they're working on, basically a jurisdiction round robin, any exciting achievements that they've had, conundrums that they've been able to solve, or issues that they'd like to request some help with. And then we'll go into our main presentation for today, which is going to look at performance improvement and best practices. And we'll do a deep dive into an ECR route that Kentucky and the ECR direct support team has been working on to process EICR messages into NBS. So that'll be the majority of today. And we've got Shravanti on from Kentucky and Lisa on from the ECRDS team. So we're really excited about that. All right. Um, Actually, I have these backwards. That's fine. Let's do jurisdiction round robin first. Does anybody, would anyone like to talk about any particular work that they're doing right now on Rhapsody or integration or Fire or beyond? Any integration challenges that you've encountered over the last couple of weeks, or perhaps some resources or tools that you'd like to ask your peers about?
Hi, this is Swati from Iowa. I have been facing an issue with the integration with Rhapsody. We have a requirement to read the records from the Amazon S3 bucket, and I don't see a COM point for reading the files in Rhapsody, and we are kind of in an older version 6.3.2. Um, for Amazon S3 bucket, I only see the output mode, not input.
Hi, Swati. It's Sean here from Rhapsody.
Hi, Sean.
Hey, yeah. So right now, and even up to like 7.5, the S3 comp point is output mode only. So, we had an improvement for input mode coming up. It was previously scheduled for 7.6 on next release, but we've moved it out a bit more because there's a few other items that are wanted. So you can use an SFTP comp point as a workaround. Actually, as I say all of this, I realize I think Jyoti has also a custom communication point for this purpose.
Okay.
Swati, are you looking for a connecting to AIMS platform? Is that why you want to pick up files from inbound?
No, we implemented a new surveillance system just a week
Uh-huh.
ago, and our HIV extract files are being dropped in the S3 bucket. So I have to read from that bucket and transfer to our program where they can access. So that's the requirement for me to do. Right now, I'm just manually transferring the files, but I was looking into a process to automate it.
Yeah, the compound that Sean was mentioning is something that APHL has developed for the jurisdictions to use through AIM for files from the AIMS platform. I'm not sure if you are able to
Oh, I
incorporate.
use that. Sorry, I
Okay.
remember now. I use it, but that has an I think there is a key, right? Access key, and
Mm-hmm.
there's another
Secret.
secret key, and there is another KMS key, I think. There's something
Mm-hmm.
else. That's the only thing which we don't have in our S3 bucket. I can get the access key and the secret key, but there is KMS key. Um, Without that, you can't use it because it says that's a required
And
field.
you're directly working with the AWS. See, like, you have um, AWS environment, and did you check with them if they can provide for that in the configuration or something that they could set it up that you're trying to connect to?
I didn't ask them directly, but I have a like an S3 details that
Mm-hmm.
I usually look it up. I was using WinSP while I was testing to connect to it, and I just only saw access key and secret key and the session ID or something like that.
Maybe we need to explore a little more on and open a ticket with
Mhm.
AWS or something, see if they have any other advice.
Okay,
Just use it because we cannot modify the compound. We are just repurposing it, what you had for AIMS platform. So we need to explore that option.
that option to get all
Mm-hmm.
the
Yeah.
required
Mm-hmm.
fields. Yeah. Okay. Yeah, I will connect with our AWS team and see if they can provide me one. Thank you for your input.
One thing, if I can add, this is Tony from Minnesota. We actually use the AWS Signature version 4 to get our files off of Ames. There's an API you can build REST COM points to construct your own signature to pull an S3 object. I'll put the link to the
Okay.
AWS signature version. And like I said, you can kind of build out on the REST COM points to do this out in COM point to pull the object in.
Okay. I will explore this and see. Thank you.
All right. Thanks for that. Any other sharing or issues folks would like to raise? All right, not hearing any. Let's look at what's coming up. We tentatively have a topic for our October meeting. I believe that's October 1st. We're going to be looking at how different jurisdictions use Rhapsody for vital records data exchange. We hope to have Virginia and Wisconsin on to talk about how they're using FHIR for vital statistics data exchange, as well as their experience onboarding with Steve and how they've been leveraging Rhapsody for both of those. And then future topics, again, we're hoping to have more in the queue, looking at artificial intelligence and Rhapsody, maybe some troubleshooting and frequently encountered issues, and then how to interface with all of your other systems, databases and cloud environments, etc. So if you've got ideas for some upcoming meetings, some topics that you really like to see explored, please reach out to me. We'd love to work with you. All right, so I can set the stage and then I can pass it over to Shravanti and Lisa for our presentation today. So the Kentucky Cabinet for Health and Family Services submitted a request with the ECR Direct Support Team to basically improve the performance of the routes they were using to ingest EICR into NBS. The route was doing a lot of things, splitting, merging, copying, and processing. And the objective was to minimize the amount of memory that was being used and decrease processing time. So the APHL Direct Support Team was working with Kentucky to redesign and improve the route. An important note here, this route is still a work in progress. It's not quite ready for production, but we thought that the example was really valuable for all of the folks on this call. I know quite a few of you are using NBS, and it also is a way to highlight some of the best practices that you can use for Rhapsody development and helps you, I think, understand how Rhapsody configuration can impact your data store. We will make the updated documentation available for the route on Confluence for those who'd like to use this as a starting point. So that's my prologue. Whoops. And I will go ahead and hand it off to Shravanti. Do you want me to share that print screen that you sent me, Shravanti?
Yes, Mel, thank you.
This one's up in here, yeah. You can't get out of here, Kitty. Yeah, we'll be here the next couple of days. If just want to get you a free quote on whatever you think.
Thank you, Mel. So for most of the partners here who are using NBS, this may look familiar to you. I picked it up from the ECR processing route, and this is how today what Kentucky's route looks like. I believe we are on that ECR version 10 route. Basically, you see there's a lot of JavaScripts, there's a lot going on in this route where once we receive the ECRs in a zip format, we kind of look for those messages. then split them back into the ECR or collect the information that we need. And then we do some more massaging by adding, generating a new global ID depending upon condition. Do we split the ECR if it's coming for Hep and COVID into two ECRs? And then we do a lot of structural fixes on EICR. Other than that, what you're not seeing, because I can fit everything on the screen, is there is one other JavaScript that we have what we called as Kentucky JavaScript, because we don't have a way, once we release a facility into production for a condition, to stop them from giving us condition that belong to, let's say we approved facility A for COVID, we don't have a way to stop them from sending hepatitis, STD, and others. And we need those ECRs for data validation. So what we do is we have a filtering in place that looks for which facility and what conditions, so we can send it to either the lower environment from production, or we even just because it's too much of a volume and we just wanted to contain it, we just chuck the others out. We don't even look at them. They don't even get into the NBS-based system. Also, what this route does is, as you know, in our NBS configurations, they gave if there is a code to condition code mapping missing, it either gets chucked out, or if it makes it into nets, it does error out. So we added one additional route where that ECRs that don't have a mapping go into that additional route for further processing. So came up with a very convoluted process to fix those missing codes on our side. So we don't have to chuck them out totally or even have an error on our NBS-based system. So this is the before. And what we worked with the APHL direct support team. Mel, do you want to take to the next screen, please? Yes. So Lisa has graciously looked at all of the code and she consolidated, and I'm sure she'll make a better justification of walking through this route than I would. But as you can see, the amount of JavaScripts have come down. That means the number of copies of each ECR that is made while it's processing through the route has cut down, in turns saving our disk storage space, and even the processing has improved. It is still work in progress. I did test with about 30 ECRs. I have had some failures, so maybe we need to go back and look at the code, and that's why we were saying it's not yet in production. But if we can make this successful and get to fruition, I could see a lot of disk space saving. At this time in Kentucky, we do have a terabyte of storage, but it doesn't seem to be enough. We have to keep cleaning our storage every 3 days or every day, depending upon the influx of ECRs and ELRs that we receive. This is just the starting. This is ECR. We do also want to clean our ELR route, which is also a big problem route for us. We just left it because it's still working and we wanted to focus on ECRs as the input files are much larger. Lisa, do you want to add anything to this?
I was just going to show a little PowerPoint slide that I put together.
Sure.
So as Servanti said, the key thing I want to point out is she said they have a terabyte of disk space on their Rhapsody server, and they're having to set their archive cleanup at anywhere from 1 day to 3 days, which is a very tiny window, especially if you need to look into maybe something that's going on in your engine and you need to look into the management console to troubleshoot. 1 to 3 days is very, very tiny, and 1 terabyte of disk space is very large. So I have did I share my screen? No, I did not. Sorry.
Not that.
So I have put together a PowerPoint, and I'll be honest, I stole this. I completely plagiarized. There is an excellent, excellent article on the Rhapsody user community that explains basically how the data store works. And I'm not going to go through all of this, but I think Mel's going to send it out afterwards if you want to go deep dive into each of the examples and so on. I just wanted to just at a really high level, go through what the data store is in Rhapsody and how your configuration can affect it. Um, in the presentation, basically, and like I said, I'm just going to go over this really quickly because I know we have limited time. But the PowerPoint presentation has an explanation of what the data store is, what it's made up of, what are the largest subdirectories in the data store, and then there's some examples of what constitutes a write to the data store. And the most important thing is I wanted to point out some Rhapsody best practices. And these are not some that I made up in my mind. These are actually on the Rhapsody documentation and on the website. And they're also, if you ever take the Rhapsody professional certification, these best practices are, if you don't use these best practices, you don't pass the certification. So these are from the makers of Rhapsody that tell you that these are the best practices to use. Your data store is actually at a really high level. You can think of it, I don't know if this thing is in the way. You can think of it more or less, your data store is a log of the activity that goes on in your engine. And that log of activity is what gives us all these beautiful details. I deleted this one, but where you can see what goes on at each point in your route. And in order to have all these details and to see, what does it look like before it goes into the filter and what does it look like when it comes out of the filter, it has to more or less log all of this information into Rhapsody somewhere. And that activity goes into your data store. The leading factors that affect your size of your data store, which is essentially your disk space on your server, is of course going to be the size of the message. And we all know that EICRs, RRs can be very large. So of course, an ECR message is much larger than, say, an ELR message. And then how long these messages are persisted in your engine. So for Cervantes' team, they have it in there for 1 to 3 days. Of course, if you increase your archive cleanup to 28 days, then your data store size is going to obviously increase. But one of the things, those two are pretty much set. You're going to get the size of the message that you get is the size that you get. You can adjust the archive cleanup, but one of the things that you can actually work with to affect the size of your data store is the configuration of your Rhapsody routes themselves. And as Cervantes pointed out, this, and I think I have some with some other things in it. I don't have the same copy she does, but you can see this route that I think there's over 26 jurisdictions that use the NBS Rhapsody routes, and it's this EICR RR route processing. And there are, in the one that I'm showing, there's over 30 filters in this route. And so I want you to keep that in mind as I go through how that configuration affects your data store. And just real quickly, these are the pieces that make up your data store. That's your body store, your meta store, your event store, indexed properties, queues, tracking, and transaction store. And I'm not going to go into each of these, but basically your the 3 biggest ones are your body store, your meta store, and your event store. And body store is pretty self-explanatory. Anytime the message comes into the engine, it's stored. Anytime the body of the message is changed, it's stored. those are all events that write to the data store. The event store is anytime that an event happens. An event might even be just going to a no-op filter. That is still an event in the Rhapsody engine, and it's reflected it in your message event tree that you see in the management console. And then there's also your meta store, and that is, of course, your metadata for your message, but it also contains message properties. Anytime you write a message property out, then there's a write to your meta store. And so just to show real quickly, this is a very simple example. You can see that when a message comes into the engine, every time anything happens, you're going to have a write to the event store. These are usually tiny, but if you have a lot of events, it could grow. But the message comes in, that's an event. The message is sent to a no-op filter, that's an event. The meta store, like I said before, that's the metadata of the message. When that message comes in, that metadata is stored. And then, of course, the message body is stored. And I'm going to skip down to another one that shows a little better. So this shows how each of these writes can happen with different JavaScript filters. Of course, your no-op filter is just a message passing through it, so it's just writing to the event store. If you have a JavaScript filter that modifies the body of the message, then of course your event is written. Then you may have some message properties that were added that writes to the meta store, and then you have the body store because the body of the message has changed. If you have a JavaScript filter that just reads the message, I'm not really sure what that would be used for, but it only writes to the event store because it did not change the message of the body. If you have a JavaScript filter that only sets some properties for the message, you didn't change the message of the body of the message, so it's it's not going to write to the body store. It's only going to write to the meta store and, of course, the event store. So you can see the different operations that cause things to be written to the data store. And if we look back at this configuration, and I'm sure probably what happened is this route has been around for a very long time, and it was probably just added to and added to and added to. But the particular things in this route that are not Rhapsody best practices and they cause issues are things like, you can see here there's 4 JavaScript filters back to back to back. And what happens is each one of these JavaScript filters changes the body of the message. So if you have an EICR coming through, which could be very large, then you're going to write that EICR to your disk space 4 times. Okay? Whereas if you had consolidated these 4 JavaScript filters into one, instead of writing that EICR message out 4 times, you're writing it once. Over here, you'll see there are 3 JavaScript filters, and they're just back to back to back. Now, sometimes you do have situations where you might need to put back-to-back JavaScript filters, but if you can avoid it, it is a very good thing to do because every time you write or you change that message, it writes to your data store. And another thing, so that takes me to, I'm going to skip way down here. The Rhapsody best practices. You want to try to combine as much as you can into a single JavaScript filter. Another thing that you can do is some of the more simple filters that are out there, like property population, search and replace, character encoding. Those filters that don't have a whole lot of functionality, if you can incorporate those into a JavaScript filter, again, that's going to affect how many times you write the body of that message to your disk space, to your data store. And in this this route from NBS, you can see like one of the very first things that happens is a property population. Well, this could have been combined with this JavaScript filter. So instead of writing to your metastore twice here, you're writing only once. There's encoding filters here, and these could have been done within the JavaScript filter. And that will reduce your filters
Much
from 2 to
faster.
1. And then another thing, and this is from historically way back. A lot of times there were situations that you could not avoid where you had to write the entire message body to a message property. Sometimes you couldn't help it. You had to do it. So when you look back at this route, in this route, there are, I can't remember which filter it's set in, but the entire body of the RR and the entire body of the EICR is written to a message property. So now you're not only writing this 4 times, because you've copied the EICR completely again and the RR completely again to a message property. Now you're writing 12 times to your data store. So you've instantly multiplied, you've instantly tripled the amount of disk space that you're taking up with these 4 JavaScript filters and writing the body of the message to a message property. Now, fortunately, Rhapsody created a new filter called the snapshot save tool.
Что ты говоришь? У меня идет это вот.
That will prevent you from having to write the message of the body of the message to a property. So the snapshot save is the little camera tool here. And that will, in essence, save off a copy of the message with a unique ID into the Rhapsody engine, but it doesn't travel with the message all the way down the route. It saves it off, and then when you need it, you do a snapshot load and you pull that back up. So that saves a lot of space when you need to save off a copy of the message. But like I said, I believe that was introduced in 6.5. So if you have an older version of Rhapsody, the alternative is to try to get rid of that as fast as you can. So the best way to do that is write that body of the message to a property as late in the route as you possibly can. And then once you've used it, like I believe this is used in the write to the NBS tables, as soon as you've used that message property, you want to erase it. You want to get rid of it. And that way you're not continuing to carry that baggage all along your route. And then a couple of other things that, of course, will affect your data store size is if you have a lot of message properties that you write out, try to be a little more conservative. Do you really need a message property written out? Because each time you save any message property, then it will write to your metastore. Indexed properties are very, very, very helpful when you're troubleshooting and you're developing a route. However, these do take up disk store space. And so if you no longer need an indexed property for troubleshooting purposes, say once you move to production, remove those indexes and don't carry it over to production because that'll cut down on some of your data usage as well. And then one last thing, this is not really anything to do with the configuration itself, but I threw this one in. because this was something that even I learned a little bit later on, is you want to try to keep your hold cues and your error cues as small as you possibly can, because of course those are just data sitting in your engine that take up space until you get rid of them. And sometimes uh, if you have something in these error cues or hold cues, you could possibly prevent the archive cleanup from working properly. Or I've also seen this happen if you have a route that, say, possibly you turned it off, but it's still receiving messages, and you have those messages sitting in your to be processed queue. That can also prevent your archive cleanup from properly cleaning up everything that it could. So that's just a little side note that I added in there. But as Cervantes said, I also took these pieces and I broke them up into 3 routes because, for one, this is just really hard to read. And breaking it up into 3 different routes is not going to affect your data store nearly as bad as, and in fact, I don't know that it affects it at all. I can't prove that it does, but it's not going to affect it nearly as bad as having these back to back to back JavaScript filters. And so with the refactored routes that Cervantes and I are working on, you can see I broke it into 3 routes. And of course, you've got your typical, is it a zipped file or not? That kind of inbound processing. These pieces here are part of the direct support request that Kentucky had, so you wouldn't normally see these unless you use that tool. But I just wanted to point out in this first route, this is my snapshot save. So that way I grab the RR, but I don't have to write it to a message property and keep dragging it along the route and making a copy all over the place. The bulk of those 4 JavaScript filters that you saw previously was all reduced to this one filter. And then these filters were part of the direct support request that Kentucky had, but essentially this will use the terminology exchange service to populate display names for some of the codes that they were receiving, but they weren't receiving display names. So that's a little tool that they wanted, but you could essentially just have this filter if you needed. And then in the final route, I just wanted to point out that the RR that I saved way back in the first route is not dragged along all of this. It's simply held in the first route and then reloaded at the end right before I need it so that it can be written to the MBS. And so that's all I wanted to share. And then Mel's going to send out this Rhapsody PowerPoint. And you can also find it on the, like I said, the user community group is where I plagiarized all this information. It was a fantastic article, but there's a whole lot of examples that are in there where you can see what kind of things, like here's a dbatch and how that was written to the message store. Does anyone have any questions that I can answer?
I got a quick one. It's a great presentation. Thanks. And I appreciate the thought about using the snapshot filter. That's a good trick. Understand that every time a message hits or goes through a filter, you write to the event log. And every time you would change a property, it's going to go to the metadata log. If you change the body, it's going to go to the body log. Do you know that if you change the body but don't touch the properties, will you still write to the metadata log? If that makes any sense.
I would have to look and see. I'm not sure.
Okay. And I reviewed. I remember reviewing this before, but I can't remember whether I dug that out or not. So. Since you were there, I thought I'd ask you. I figured you knew everything.
Yeah, that's a good question. I am not sure.
Oh, it's Sean here. Hi, I can jump in there for that
I
one.
suspected
Okay, yeah.
I
I
did have to look
suspected
that
you
one
might
up.
know.
No, every time you write, every time something gets written to the body, it also gets written. The meta still also gets written too.
Okay, that kind of makes
Okay.
sense. I was just curious. Thanks.
Thanks, Sean. I wasn't sure about that myself. I noticed that on some of the examples that were in here, but I didn't dig into it far enough.
We should have called that one out. And I also had that question early on, so that's why I happen to know.
Okay. Does anyone else have any
Yeah,
questions?
yeah, I have a question. Yeah. Thank you for the presentation. With this, with this filter, there are times that I just want to know if we can configure the filter. There are times that we receive, for a particular case report, we receive duplicate for the same report. If we get it 4 or 5 times, with this, is there a way we can use the JavaScript filter to detect that one? If okay, this is a duplicate of the file that has been present and that has been sent, and then rather than just notifying, we get duplicate 4 times, we notify 4 times. I want to know if there's a way we can possible with this to use the JavaScript to filter to detect previous process
Um,
reports.
the JavaScript, there probably is, but there actually is there's a duplicate message detection filter in here. And I am not sure what version it was introduced in, so I can't promise to say it's available depending on your version. This one, duplicate message detector. However, I believe that there's also some work being done on the AIMS side to prevent these duplicate messages. I'm not sure where that development's at and what's going on, but I'm pretty sure it's in progress. And then the third thing